In 1980s Britain, the Sinclair name was synonymous with home computers. It was also synonymous with cheap design, terrible keyboards, and long wait times to fulfill orders. Their second computer, the ZX80, had all of this and more, but with clever marketing and a very low price, less than £100, it kickstarted a British computer revolution and helped to cement Britain today as a home of programming excellence. And yet, the leader of the company that made it, Clive Sinclair, wasn't really interested in making computers. So why did he produce it? And why was something so flimsy and underpowered so influential? This is the Sinclair ZX80 story. Clive Sinclair had been selling electronic gadgets since the late 1950s, starting with transistor radios. By the early 1970s, he'd moved into pocket calculators and a digital watch, the Sinclair Black Watch, and sometimes both, like the Sinclair Wrist Calculator. But the Black Watch wasn't a success. It was utterly unreliable. Meanwhile, Japanese competition were eating into pocket calculator sales. Sinclair pivoted to a pocket TV and thoughts of making an electric car. The TV would launch as the Pocket MTV-1 in 1978, but it was a commercial failure. Sinclair was encouraged to look at producing a computer when new employee Ian Williamson presented a potential product using the National Semiconductor SCAMP chip, a low-cost 8-bit chip that was more useful as a microcontroller for lifts rather than a home computer. But it was cheap, and one thing Sinclair was good at was producing low-cost and sometimes low-quality versions of more expensive products. The project was put under the control of Chris Curry, and the result was the MK14 that launched in 1978. It was similar to Commodore's KIM-1 that was a precursor to the PET. Sinclair was honest about what this really was. It was an introduction to computing for the hobbyist, or something to build into a larger electronic system. For just over £40, the MK14 was a good deal, but that low price came with a catch. You had to assemble it, so you better be good with a soldering iron. But it was a real 8-bit computer with a simple touchpad, keypad and calculator-style segmented display that could be programmed to do real things. The SCAMP chip had its limitations. It only had a 12-bit address bus, meaning memory was addressed in 4 kilobyte blocks, with awkward bank shifting needed to address more memory. The interest in the MK14 and the demand for computers like the TRS-80, PET and Apple II, both in North America and Europe, showed there was money to be made in microcomputers. Chris Curry wanted to produce something of the quality of the Apple II, but there wasn't enough cash to launch a project like this, so he parted ways with the company. Sinclair's investors agreed to fund a new machine. The decision was taken to use the new Z80 processor starting in the summer of 1978. But this project would be completed without Clive Sinclair. He'd had enough of the investors meddling in his company and of its financial difficulties. He left to head up another shell company he'd created, Science of Cambridge, leaving this company to complete the computer that would launch as the new brain in 1982. Although Clive Sinclair had visions of another small TV and an electric vehicle, this new company needed money to finance them. Computers were a hot commodity, and the MK14 had proved to be a modest success. Sinclair's new company began work on a project similar to the new brain. From the outset, it was designed as a very simple machine. Clive Sinclair had a flair for cutting a product down to its absolute bare essentials, sometimes to a point that they were barely usable. This was the absolute opposite of Steve Jobs, who focused on making high-quality, robust products that were very usable. Work on the computer that would become the ZX80 began in May 1979 with many of the same people as the new brain, so it's unsurprising they chose the same Z80 processor. While Sinclair might not be very similar to Steve Jobs, there are a lot of similarities between the team that designed the ZX80 and Steve Wozniak. Both were very good at creating something usable out of a very small amount of components. The MK14 used a small calculator screen, but for a similar cost, the computer could be hooked up to a TV screen. Like American Micros, it could store computer programs on cassette tape. To reduce costs, the same circuit board that held the electronic components doubled as the keyboard. The ZX80 was simply a circuit board with a keyboard membrane and a flimsy 1mm thick white plastic shell covering it, even with black lines stuck on to make it look like it had a vent. This was a project that wasn't driven by features but by price. It had to retail for less than £100 and still deliver a tidy profit. Production of the programming language was farmed out to 9 Tiles of Cambridge. BASIC had been chosen for North American microcomputers because of how many students were already familiar with it from their days at college. There was no such history in the UK, but BASIC was chosen for Sinclair's computer mainly due to the large amount of documentation available to create a BASIC interpreter for Z80 machine code. Languages such as Forth might be more powerful, but that wasn't what Sinclair was looking for in the ZX80. He wanted something accessible to the masses. BASIC was easy to learn and compact. ROM chips were expensive, so the team were told to make it fit into a minuscule 4KB ROM chip. Given that size, what 9 Tiles produced was highly innovative. Instead of the editor having to parse what was typed and turn it into machine instructions, the user instead pressed keys that corresponded to BASIC keywords, and the line editor checked for syntax errors on the fly. This freed up ROM space to include simple string handling functions. But with the 4KB ROM also holding the character set and the screen editor, 9 Tiles were very limited on which BASIC instructions could be included. The ROM was more or less complete by the end of the summer of 1979, but it would take until October until the hardware was ready. The new company was running on fumes, so Clive Sinclair sold his house and his car, a Rolls-Royce no less. This computer had to succeed. Production ramped up in a St Ives factory and marketing copy was readied for the big push. The Sinclair ZX80 launched at the Wembley Computer Fair in January 1980. Like the MK14, it was available as a kit for £80, but could also be received as a fully built computer for £20 more, coming in at just under the £100 self-imposed limit. Although you'd need to stump up another £9 for the power supply if you wanted to actually use your new computer. Maybe some early customers got annoyed they just bought a computer that wouldn't work without a power supply, so Sinclair soon started bundling the power supply with fully assembled computers. I'm sure one of the first questions journalists asked Sinclair was, why is it called the ZX80? Apparently it wasn't named after the year at launch, but for the Z80 processor with the X added for the mystery ingredient. Many small companies had released microcomputers in 1980, but what made the ZX80 stand out was its marketing. It was sold in newspapers and magazines read by people with no knowledge of computers at a price that meant it was worth buying to see what all the fuss was about. Like many adverts, it promised more than it could deliver. For example, it couldn't be used to manage a business or, God forbid, run a power station, but it could qualify as a business expense that could be written off, giving yet another reason to give the ZX80 a try. If you didn't want to jump right in, Sinclair could sell you the operating manual on its own, and its cost could be deducted if you went on to buy the computer.
And now we're on the brink of the computer revolution. It'll run its course not in a century, but in 1 or 2 decades. It's an era when we'll amplify the power of our brains many, many times in the way that the machines of 100 years ago amplified the power of our muscles.
The ZX80 came out at just the right time. TV shows like The Mighty Micro were talking about the impending dominance of computers and how they would take over almost all parts of everyday life. You better get on board or get left behind. This was a virgin market, and Sinclair ZX80 found a ready audience. The odd keyword entry system takes some getting used to today, but in 1980 most people hadn't touched a computer before in their life, so there was nothing to unlearn. Typing in keywords was relatively straightforward on the ZX80, but became a diabolical form of torture on the ZX Spectrum when the number of keywords ballooned. It led to a lot of odd key combinations to get the necessary keyword. But reviewers loved it on the ZX80. Once users got to use it, it made typing basic programs much faster, handy as the terrible keyboard definitely made it slower. Maybe slowing key presses down was a good idea, as modern emulators with modern keyboards shows it takes the ZX80 time to register each key press. With no travel and no sound, the keyboard gave you no feedback, so you were constantly switching your gaze between the screen and the keyboard to find out if the computer registered the key press. The ZX80 could either run code or display things on the screen, not both. That meant displaying things, then waiting for input, which made it impossible to play arcade games. It also meant that when editing code, the display would keep jumping, making for a seizure-inducing experience. The ZX80 came with just 1 kilobyte of RAM, that's just 1024 characters, and that was shared between the program and the screen display. The system of entering basic keywords helped somewhat, as each keyword was only 1 byte, and that made it more compact than competing systems. As you started running out of memory, something that would happen very quickly, the screen would shrink, which was at least a good visual indicator that you should stop typing. But it wasn't likely you'd be writing complex programs given the limited basic. Go subs couldn't be nested, there were no string arrays, no string concatenation, and most importantly, no floating point numbers. In fact, numbers could only be in the range of minus 32,768 and 32,767, meaning the computer would be very limited in what it could do. There was the ability to enter and run machine code using the poke, peek and USR commands, but good luck discovering what the computer could do with limited documentation on the computer's architecture. Like the Commodore PET and the TRS-80, there were basic blocky graphics made up of characters, but with no way to position the characters on the screen, it made even simple graphs and bar charts a difficult prospect. The ZX80 had no sound, but it didn't stop some from discovering how to hack it. One program used the routine to output sound through the mic socket as if the computer was saving a program. Another method worked by creating a buzz on the TV speaker while the computer was thinking by giving it different things to think about. The jumpy screen and terrible typing experience meant for a bare bones pretty awful computer, but then what should you expect for the price? I've talked in my TI-99 video that for the price of that computer, today you could buy everything on the screen right now. Computers were seriously expensive back then. The ZX80 was completely different. It could be had for the cost today of a mid-price smartphone. For that sort of money, many could take a chance to see what this whole computing thing was all about and maybe train themselves up to become invaluable at work when the boss bought an Apple II or a PC to do something serious. Everything was included in the box to get you started, other than the TV of course. The team had clearly looked at American computers and copied the easy-to-use operating manual, even with a quick start guide that told you which keys to press to create your first program. More than one review stated it was cheaper to buy the ZX80 and learn basic programming with the operating manual than take a course in computing. And it wasn't like most customers were comparing this to something like an Apple II. They were comparing it to not having a computer, and the ZX80 was fascinating. It was essentially a toy, but it was a fascinating toy. What the ZX80 offered wasn't a machine that could save you time at work or balance your finances. It offered a relatively cheap way of experiencing something that was going to revolutionize the 1980s. 8 months after launch, 20,000 computers had been sold. With a growing backlog of orders, Sinclair moved production to Timex's larger factory in Dundee. Customer wait times got very long, something that would become a Sinclair tradition. When one patient customer who'd been waiting for 5 months heard Sinclair would soon sell the ZX80 in the USA, he sent a letter full of beautifully British dry wit.
Dear Mr. Sinclair, I was interested to see that you intend marketing the ZX80 in America. Perhaps before attempting to deliver to the States, you could try delivering to Colchester, Essex, UK, a distance of 40 miles instead of 4,000. Sincerely, D.J. Harper.
Many thanks to Nostalgia Nerd for the wonderful rendition of that letter. He does some great retro computer videos, including the history of the ZX Spectrum that's linked above. Anyway, despite customer protestations, Sinclair did start selling the ZX80 in the USA at the end of 1980. The circuit board had been designed with the US in mind. One extra diode turned the 50Hz machine into 60Hz. The US had challenging RF interference rules, but in typical Sinclair fashion, their cheapskate solution was to spray the inside of the case with metallic paint. It cost $199 for the fully assembled version, and oddly the same amount for the kit, and it was only available by mail order. It was less than half the price of its nearest mainstream competition, the $499 TRS-80. That might seem like a great deal, especially as the ZX80 was faster in benchmarks, but the TRS-80 came with a monitor, a cassette recorder, a real keyboard, and 4 times the memory. It might cost a lot more, but then it offered a lot more. Although reviews of the ZX80 stateside were largely positive, sales were slow. Sinclair also offered the ZX80 on the continent, using all the British stereotypes in the process. When the ZX80 launched, it only came with a measly 1 kilobyte, but there was an expansion port that promised so much more. Sinclair offered what they called memory expansion boards that could add another 3 kilobytes. These could be daisy-chained to offer up to 16 kilobytes, but at £12 for each board and £16 for each 1 kilobyte of memory, it added up quickly, especially for such an inexpensive machine. By 1981, Sinclair was offering a better deal, a 16 kilobyte RAM pack for less than £50, which showed how quickly the price of memory was falling. It also brought in the era of the dreaded RAM pack wobble. The top-heavy design meant that touching it could crash the machine, losing hours of coding. Sinclair also announced an improved 8 kilobyte ROM that would soon be available with support for floating point numbers. Sinclair's marketing was changing as well. This was now being sold as a family learning aid. Apparently children 10 years old were quick to understand the principles of computing. Well, one boring, probably rainy Sunday when I was 10, I discovered our ZX80 that had been discarded by my parents. They were one of those people who thought that they'd try it to see if it could give them an insight into how computers could help their business. The Quick Start Guide showed me how to write a program, and I was encouraged to read the whole manual. That easy-to-use guide helped me learn by doing and inflict my terrible programs on the world. As it was produced with off-the-shelf components, cloning the ZX80 was simple. There was a clone in Brazil, the Nova Electronica Z80. The US MicroAce kit was a blatant rip-off that sold in Australia and the USA. There was one noticeable difference. The MicroAce had white text on a black screen, although that could be achieved on the ZX80 as well by cutting one trace and bridging another. Sinclair sued and the makers of MicroAce settled, turning it into an officially licensed clone. Production of the ZX80 naturally ended when Sinclair launched its replacement, the logically titled ZX81 in 1981, finally with a stable screen and a much expanded BASIC using the promised 8 kilobyte ROM. The computers were so similar, Sinclair offered ROM upgrades to turn the ZX80 into a ZX81, which also allowed it to use the new ZX printer. But the ZX81 was better in so many ways. The 21 chips had been amalgamated down to just 4 thanks to a custom ULA, something that Sinclair could afford to produce after the success of the ZX80. This made the ZX81 cheaper to produce, which allowed Sinclair to continue to lower the price of their budget machine. It would help ZX81 sales dwarf that of the ZX80 and fill Sinclair's coffers. Whilst over 50,000 ZX80s were produced, the ZX81 sold around 1.5 million. Third-party improvements to the ZX80 appeared even while it was being sold. DK-Tronics produced a ROM to add an additional 448 custom graphics, as well as a usable keyboard. At the end of 1980, Macronics found a way to divide time in software between running code and displaying the image, meaning arcade games could finally be produced. Their first game, Breakout, brilliantly showed off this effect. They followed it up with Space Intruders in 1981. Quicksilver also released Defender that same year. The release of the ZX81 would spell the end for any more work on ZX80 software improvements. That is until much later, when people like Paul Farrow took a stab at making the ZX80 perform the impossible. He produced an excellent conversion of Pac-Man in 2010 along with several other games, but more came with the Chroma 80 interface, a development of the Chroma 81 interface for the ZX81. As well as providing more memory, a joystick port, a SCART socket and a ROM cartridge slot, it offered colour in 16 shades. This allowed games like Kong to be released. In 2025 he converted the 1984 ZX81 custom graphics Rocketman game to the ZX80 in colour, making owners of the venerable machine amazed at what could be wrung out of it 45 years after it launched. If you want to see more fascinating ZX80 games, click the link above to an excellent video from the YouTube channel Shareopolis. People at the time bemoaned the keyboard as being brittle and easy to break, but 45 years later mine is still going strong, which is more than you can say for other computer keyboards, but maybe that's due to the utter lack of movement in this keyboard. As for Clive Sinclair, the ZX80 was a means to an end. He wanted the revenue to continue his aspirations of producing a smaller pocket TV and electric cars. The ZX81 and ZX Spectrum would allow him to realise those ambitions, but both the TV and the car would be a failure. The ZX80 was just what was needed in the UK in 1980, a relatively cheap computer to seed the market, to get customers familiar with what a computer could do. In North America, computers were fully featured but expensive, which limited them to the well-off or those really committed to buying one. With full-page adverts, the ZX80 got people's attention, and it was cheap enough to allow people to give it a chance. When the even cheaper ZX81 turned up in high street shops, buying one was a no-brainer. This fueled a new wave of teenage software engineers. When they started work, they produced a wealth of excellent software that's been exported all over the world. This all started with the cheap and cheerful Sinclair ZX80. Chris Curry, the head of the MK14 project, decided the UK needed well-designed and assembled computers and forged out on his own, creating Acorn Computers. It's a company that would produce a chip design that's in almost every electronic device today. But it's Acorn's first consumer computer that we'll look at in the next video, the Acorn Atom. When the Acorn Atom video is ready, it'll be linked on the right. If you want to see how I got on fixing the amateurish first ZX80 game I had published in 1981, click on the other link. Thanks for watching to the end, and I'll see you in the next video.